Hello, everybody. For this particular lecture, we're going to be talking about the sort method and how does sort work. So the sort method is going to be in your learning platform. I got logged out somehow. Okay, but let's continue. So module 5.6, sort. So sort is a built-in array method that allows us to sort items in an array. So let's take a look at how we can sort things. And I'm going to go ahead and put this with the code. Go ahead to the sorting section. All right, so we have an array of parts. In this case, we have an array of objects. But let's also get some other types of data like const nums is equal to, let's put some numbers that are not sorted. 7, 5, 9, 3, 2, 4, 10, 1. Okay, so these elements are numbers right here inside of the array. These are the elements and they're all numbers. So nums, so I can actually do nums.sort, and I'm going to give it a callback function. Now this one is a little bit different than the find, filter, map, sum, and every methods. It's similar that it's going to accept a callback function, but what it's going to do, one thing that's different is it will modify the original, right? The dot find, filter, map, sum, and every, none of them modified our original array. It just find would just give us back an element from the original array that matched a certain condition. Filter would give us back multiple elements that match a certain condition, or it'll give us back in an array, multiple elements. Map would transform the original array, but it would give us a new array that has the transformed version of the original array without modifying the original array. Sum would give us back true or false, and every would give us back true or false. None of them modify the original array. But sort, it'll modify the original array. That's one thing. And another thing that's different is the parameters are different. First, so let's talk about how the parameters are different. So you're going to give it two parameters when you want to sort. It's going to compare two things at a time. For example, it's going to loop through this whole array. And in the first iteration, it's going to compare the first element with the second element. It's going to compare these two. So we can represent that as element A and element B. In this case, you can name it anything you want though, but it's going to be two words, element A and element B. And what we're going to do is we're going to return. So if you return a negative number, -1, it will move element A before element B. If you return a 1 or a positive number, let's say negative, it will move element B before element A. So that's what it's going to do. Hold on one second. Sorry, I had to pause for a second to help a student. Anyways, so if you return a positive number, it will move element B before element A. So in the first iteration of the sort loops through the array, but in each iteration, it's going to look at two elements at a time, element A, element B. And it's going to compare these two. And let's see what we can do. If you return a 0, it does nothing. It doesn't swap them. So negative number will move element A before B, right? So if I return a negative number, it'll move 7 before 5. If I return a positive number, it'll move element B before element A, and element B is 5, so it'll move it before element A. So it'll make it look like this. Oops. It'll make it look like 5, 7. That's what it would do. And then it goes to the next iteration and it does the same thing until it's fully sorted. So we can sort it in ascending order or descending order. So let's take a look at what we can do. So we can return, if you just have a bunch of numbers, if you're sorting numbers, you can just return in a couple ways. Now, do you want to sort it ascending or descending? If you want to sort it ascending, meaning from least to greatest, we'll return element A minus element B. And this is going to give me, for example, in the first iteration, element A is 7 and element B is 5, right? So what is 7, element A, minus 5? That's going to be 2. It's a positive number. So if it's a positive number, if we return a positive number, what will happen? It will move element B before element A. So in this case, it would move element B, which is 5, before element A, which is 7. So it would actually swap these two. It would move it like this. And then in the next iteration, it's going to look at these two elements, 7 and 9. And it's going to check. So element A is 7, element B is 9. And it's going to return back 7 minus 9. What is that? 7 minus 9 is negative 2. So negative number. It will move element A before element B. Well, element A is already before element B, so nothing happens here. And then in the next iteration, it will check here, and so on. It will continue to do this, and it will eventually sort this out. It's not quite like a bubble sort, but it'll just sort. It'll sort it like this. Basically, if you have numbers and you want it ascending, do element A minus element B. So let's see what nums looks like. Oops, wrong button. Node. Look, it's fully sorted. It's fully sorted here. So it's sorted in ascending order. This is how you do ascending order. And notice it modified nums, right? I didn't have to store this result in a variable. Nums is already modified when you do dot sort. That's one thing to keep in mind. And let's go ahead. I'm going to just create a function. Just so I can put all this inside of that function. And let's say it's going to be given nums. Cool. So now if I were to call sort ascending with nums, it will basically just sort my nums. So let's see what it looks like. Nums will look like this. Let's talk about descending. Or let's call this data. And just know that the sort only works on arrays. So I'm going to say data is equal to an array. Because maybe I might not just get nums. Maybe I might get other types of data too. So sort descending is going to do something similar. Except let me get rid of these comments here. Except we're going to do element B minus element A. That's the difference. This is going to sort descending. One way to memorize this is if you name your parameters like A and B, if you want to sort descending, B and A, right? It goes B minus A, B A, like Bah, I'm a sheep. Bah. But imagine a sheep falling down into the off of a cliff. Imagine a sheep falling off of a cliff, and it's just like, bah, I'm a sheep falling down. So descending, it's going down, just like the sheep that is falling off of a cliff. I don't know. That's something that's how I memorize it. So there we go. So this will sort it so that it is descending. If you do B minus A. If you do A minus B, if you return A minus B, it will do ascending. And that's if your data is just simple numbers. But what if we have something with, instead of sorting with nums, let's take a look at what sort descending looks like real quick. Sort descending, as you can see, it's in descending order. Just wanted to make sure I verified that first. Cool. Now, what if our data is not just simple numbers? What if I have an array of objects and I needed to sort them based on this information? Sorting given an array of objects. So let's sort this array of objects. So for this array of objects, sort parks ascending. Let's say it takes parks list is equal to an array. When I call it sort parks ascending with parks, with this parks array, let's see what happens. Okay, we need to sort this parks list. Parks list dot sort, and I give it a callback function. And inside the callback function, I need two parameters here: park A, park B. So it's going to look at two parks. It's going to compare two parks at a time. And if I give back, so how can I sort them by rating? Well, I need to do, park A represents the whole park object, and park B represents a whole park object. So to get access to rating, I would do park A dot rating. Right. So now we can get numbers where we can do subtraction. Just like earlier, we could do element A minus element B directly because these elements are already numbers. Here, these elements are not already numbers. So in order to get the number from them, it's dot rating. So A minus park B dot rating. So A, B, imagine just it's going up. It's going in order, right? A, B. So when you return A, B, that means it's going from least to greatest. Well, let's just return parks list and see what that looks like. There you go. It's going from lowest rating to the highest rating. So that's how you do it with an array of objects where you're sorting by the number. You can pause this video and ask yourself, how would I do the parks descending? Go ahead and pause it and think about it and then play the video again for the solution. All right, welcome back. So sort parks descending. Bah, I'm a sheep falling down. Park B, park A. Bah, it's also going down, like in alphabetical order, it's going down. So I guess you don't even need that obnoxious analogy at all. It's just going reverse. So it's going down, it's decreasing down the alphabet, right? B minus A. That's going to make the ratings, it's going to show me the ratings in highest to lowest, decreasing. Well, let's call this sort parks descending. And there we go. And now I have access to ascending as well. That does the other way. Perfect. I usually ask any questions, but this is me recording this. So if you have any questions, feel free to ask it in the Discord, in the general help channel. Well, I don't have it on this monitor, but yeah. Cool, that's how you sort an array of objects based on a number. Now, what if I needed to sort strings? So let's just go ahead and I'm just gonna go ahead and write some comments here. Okay. So what if I wanted to sort strings, sorting strings? Like in alphabetical order. What if I wanted things to show up in alphabetical order? So let's say I have an array, let names is equal to, and let's just go ahead and put the greatest basketball players that are currently playing right now in the league. Okay. Luka Doncic. Okay. And then let's do someone that starts with A. I don't know anybody that starts with A, actually. I don't know why, but that's fine. Let's do LeBron James. Let's do Kevin Durant. Let's put Steph Curry here just to make it out of order. So that you can see this is definitely not alphabetical order right now. Right? Oh, we also have Anthony Davis. Okay, cool. As you can see, this is not alphabetical order at all. And let's put like Baron Davis. Okay, so this is not alphabetical order. It's not in any particular order right now. But if I wanted to sort this array of names alphabetically, because I'm sorting strings alphabetically, I can also do that. Names.sort. Let me actually create a function here. Sort names. Okay, and it's going to accept a names list, or you can call it anything you want here. And if I call sort names alphabetically with the names array, okay, so I'm going to sort names list. Names list.sort, give it a callback function. And here I need to give it 2 parameters. Let's call it name A, name B. It's going to look at 2 elements at a time. Each element is already a string, right? So each element, name A and name B, represents strings. Name A, name B, and so on. So for strings, how can we return? We can only return, for the dot sort, you can only return a negative number, a positive number, or a 0. And if you return a negative number, right, let's put this code comments here again. If you return a negative number, it will move element A before element B. If we return a positive number, element B goes before A. 0, it does nothing. Okay. So how can we return a negative number? We don't have any numbers to subtract this time. So the way that JavaScript works when it comes to letters, it is, you can actually compare letters, like A is less than B. Because A comes before B in the alphabet, JavaScript thinks A is less than B. And if I run this, you'll actually see that it says true. Is Z less than B? No, Z comes later in the alphabet. So JavaScript thinks of it as it's greater. So Z is not less than B. So it would give me false for that. So is Z greater than B? That's true. Okay, cool. So that's how JavaScript works with comparing strings. When you compare strings like this, it'll give you true or false based on their order in the alphabet. However, check this out. If I say A is greater than B, says false. It treats capital letters differently though. So, okay, if I do A is less than B, it says true, and A is less than B, okay. Still works. How am I supposed to, I'm trying to get this to break. Hold on. Oh yeah, when you compare A with A, it doesn't think that they're equal. Right? Is A equal to A? No, they're false. Is A greater than A? True. Oh, it looks like a lowercase version is greater than an uppercase version. So you got to keep that in mind as well. But for now, let's just make it so that we're just comparing, you know, all lowercase. So A is not greater than B because A is before B in the alphabet. So that's how it works. Okay, so let's just think about lowercase numbers, letters for now. So knowing this, we can actually say if name A is greater than name B, meaning if name A is later in the alphabet than name B, right? So in this case, the letters, it's going to look at each letter, but Steph Curry is name A, and then Luka Doncic is name B, right? And it's going to check the first character of both of the strings first. So it's going to compare the S with the L. So is S for Stephen Curry greater than L for Luka Doncic? Well, S comes later in the alphabet than Luka. That's true. So if that's true, do we want to swap them to flip the order to make it alphabetical? Yes, we do. So in order for them to swap, we need to return a positive number. So that's how it is. So if name A is later in the alphabet than name B, then return a 1, and 1 is going to switch their positions. So keep that in mind. Right here. Cool. So let's see what we get. Names list. As you can see, they're in alphabetical order. Now, what if I have another person named S, starting with S, like I don't know, anyone else that starts with S? Sarab, that's me. What's up? Okay, so that's my full name. So they both start with S, so then it's going to check the next character, like T compared with the A, and it looks like Sarab comes before Steph. So in that case, you can see Sarab comes before Steph here. Cool. Now, what if some of our data is lowercase and some of our data is capitalized? And what if I have this lowercase, right? Let's see if it still works. Uh-oh, it doesn't work anymore. The lowercase ones are treated as higher in the alphabet, even though they're all the same alphabet, right? But it actually treats uppercase letters differently than lowercase letters. So we want to make our data uniform by comparing the lowercase version of both names. So I could say name A dot to lowercase. This is going to say, hey, let's just compare the lowercase version of the name. So it's not case sensitive. So when I do dot to lowercase of the two names, now it's going to compare them as if they're all lowercase. And now it's going to sort it properly. Right? You see Steph Curry's at the end now. Whereas earlier, Steph Curry was before all of the lowercase ones. So now it doesn't care about the casing. It's going to compare them all as if they're lowercase. And it's going to sort them as if they're all lowercase. But then we still get it sorted. That's ascending order alphabetically. But if name A is greater than name B, if I wanted to sort them in the non-alphabetical way, like I don't know the word for it, the opposite of alphabetically. What's the opposite of alphabetically? Unalphabetical? Okay, sure. This is called a reverse alphabetical. Yeah, reverse. Okay, interesting. Okay, I'm probably not gonna use that one. Okay, so let's just call this reverse alphabetically. I don't know the word for that. So in this case, I would just flip these two, minus and plus. So if I call reverse alphabetically, you should see them in the reverse order. So that's something to keep in mind with sorting strings. Now, what if I wanted to sort the parks alphabetically? Okay, so to sort the parks, let me just split screen so we can actually see our data on the left side. Parks, okay. So we're going to be sorting an array of objects alphabetically based on their name. Alphabetically, okay. Let's call this parks list, sure. Sort parks alphabetically, pass in the parks array. And once we do that, we can take a look and see what we can do here. Okay, so sort parks alphabetically. It's actually very similar to this. I'm just going to go ahead and copy this. It's the same exact logic, but let's just call it, you can still call it name A and name B, but they represent park objects. Let me call this park A. And then let's just name this park B. So I made it also switch here. Now I'm not comparing park A. What is park A? Does it give me Biscayne? No. It gives me a whole object. So I can't just do two lowercase on a whole object. I got to do park A dot name dot two lowercase. So I can get the name of the park comparing with the name of the other park. Then I should be able to see the parks. Names list is, oh, I call it parks list. Parks list. And you can see that they're sorted. Well, this is the non-alphabetically. This is the reverse order. So just to make it alphabetically, this is alphabetically. I didn't know G came before I, but now I know. Okay, A, B, C, D, F, G, H, I. Yep, that's right. And then to do the reverse, you just do -1 here and then +1 here. I could create another function for that, but I'm not gonna. It's the same thing. It's just gonna be these two are flipped. Cool. Let's do this. Let's put some dirt in the game here. Let's sort these parks based on the length of their name, park names. So the longest park names will, well, I guess it's already at the end. Let's say this is a Biscayne, the thing. No, man. Okay. So, okay, obviously this is the longest name. And then let's just call this Grand. This would be the shortest name. Okay, and what if I wanted to sort them so based on the length of their park names? So this should be at the end. Grand should be at the beginning. I think these two, I don't know which one's longer, but these two should be in the middle. So I want to sort them based on how long their park names are. I can do that. let me just copy this, paste it here, sort parks by how long the park name is. I don't know, long function name, but that's okay. Sort parks by how long the park name is. Okay. It's the same concept, but here I am comparing something else. I'm comparing, instead of if the name, like if instead of comparing them based on the names, I'm comparing them based on the how long the names are. So in that case, I'm actually comparing numbers, because I'm comparing how long this is versus how long this is. So maybe this is like 20 characters and maybe this is 5 characters. I don't really know how many characters this is, but maybe this is 20 characters and maybe this is 5 characters. So I want to sort them based on the number of the name dot length. So park A dot name dot length minus park B dot name dot length. Because remember, this is going to give me a number. So I'm doing a number minus a number. So that will actually give me a negative number or a positive number or 0. Because this is a number minus a number. Name dot length, maybe this is 20 characters and maybe this is 4 characters, right? So 20 minus 4, that gives me a positive number. And if it's a positive number, it will switch it. So it'll flip these two, this one and this one, it'll flip them. Let's see what we get here. Cool, we get it in this order of shortest park names to longest park names. Perfect, okay. That's it for the sorting one. You can expect something similar to this in your assessment. Thank you, and have a good day.